All right, lesson 2 in unit 3 focuses on our next set of transformations, which is going to be translations. We talked first about reflections in the coordinate plane, reflecting over a vertical line or a horizontal line or a line through the origin. And now we're going to talk about translations, which is essentially just moving to the left or to the right. All right, and so as we, oh, my clicker is not working. Oh, this is a bummer. Oh, there it goes. Okay, good. So our job here is to describe the properties of a figure before and after a translation. The big deal here is, can we move it in the coordinate plane and then tell what changed, all right, if anything, right? Basically, we're just changing its location. That's what a translation is. So again, here's just some descriptions. I think that all of this information is very valuable. I would love for you to have all this stuff. There's some key pieces, though, that are just sort of an absolute necessity. And that's kind of the key notation that we use. All right, we're going to practice writing this notation throughout this unit, whether we're talking about a reflection, a translation, a rotation, or some combination or composition of those transformations. So in a transformation, when we move triangle ABC back and down, or if we move it diagonal, we're going to notice that each of these segments connecting A to A prime, B to B prime, C to C prime are all parallel to each other. All right, we should see that they're parallel, but we should also see that they are congruent to each other. Each of those segments are congruent to each other. The triangles have the same orientation. They're just changing where they are. They're not reflecting, they're not turning, they're facing the same directions if you want to consider it that way. They're just moved left or right, up or down, or again, some combination of left and right, up and down. Since it's a rigid motion, the length of each segment, the measure of each angle, those are all preserved. Those are all preserved, which is really important to be aware of. So have this information down so that we can reference that throughout our thinking when we are in class together next time. So here we're going to find the image for, or the translation of, the translation forward 6, down 5 of triangle EFG. So again, the first number is our change in X, whereas the second number is our change in Y. What are we doing here? So our change in X is going to be forward 6. Our change in Y is going to be down 5. And here's where this is maybe a little confusing, because we're used to talking about rise over run. We're talking about the Y's before the X's when we talk about slope. But here, when we talk about X comma Y, X comma Y, X comma Y, and then the change in the X, comma the change in the Y on our translations. So to find where E prime, F prime, G prime are located, we're going to take each of these X comma Y's and we're going to move them forward 6 on each of the X's, down 5 on each of the Y's. Now you can compute that without having the graph paper, which I think is valuable to understand. That E prime is going to be -5 plus 6, comma 4 minus 5. That F prime is going to be -1 plus 6, comma 5 minus 5. And that G prime is going to be -2 plus 6, comma -1 minus 5. All that we're doing is we're changing each of the X's by moving it forward 6 spaces, which is adding 6. We're changing each of the Y's by bringing it down 5 or subtracting 5 from each of those Y values. Seeing it visually, we can see what plus 6, 1, 2, 3, 4, 5, 6, down 5, 1, 2, 3, 4, 5 is going to give us for E prime. Does that make sense that for E prime we have -5 plus 6 makes 1, 4 minus 5 makes -1? Did we end up at 1, -1? Ooh, we did. And so we can see it worked out step by step over here, or we can see it manifested in the graphing by showing that we are moving this forward 1, 2, 3, 4, 5. I'm sorry, 6. I can count. And then down 1, 2, 3, 4, 5 to get our F prime. All right, we got 5 comma 0. And then over here we should have G prime is 4 comma -6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And that is our G prime. Once we have the dots plotted, we can connect each of those segments using our ruler. Again, required class material. Although we're not measuring these, Sometimes it's useful to measure those and make sure that we have the same length segments as our original drawing. But here you can show that this triangle has moved forward and down. All right, forward 6 and down 5. I would love for you to try to do this translation here. All right, where we are going to translate the same original triangle, but we're going to translate it 4, -3. Can you do the 4, -3 in the coordinate grid and or with the x, y's? We want you to identify each of the x, y's for e prime, f prime, g prime. You can either find those and then graph it, or you can graph it and then tell what each of those are. So there's kind of 2 approaches that you can choose to do, but you're going to try to do this one. That's example 1b. Example 2a, given the figure, write the rule. Here we have the pre-image and the image. So what has happened? This has moved forward and it has moved up. It's moved forward 1, 2, 3, 4, 5 spaces. It has moved up 2 spaces. So we are going to say that we are translating forward 5, so a +5, up 2, so a +2 of point P gives us point P prime. This is the way that we are going to write these sentences that describe our translation rule. All right? So we capital T in these, it looks like greater than less than signs. It's not what they are, but there's these kind of pointed brackets. The x change, the y change of the thing that we're moving gives us all the points prime. So if we had a triangle in here, ABC, we'd have triangle A prime, B prime, C prime, or triangle EFG, E prime, F prime, G prime. All right, so over here, let's write this rule for what's happening between the original triangle here, again with our change in x, our change in y, of our figure, which we can go in alphabetical order, S, T, U, V. It does not matter, but we should pick a point and go clockwise or counterclockwise or whatever. And we're going to get our S prime, T prime, U prime, V prime. All right, but we have to figure out what the x, y change is. And so this is the piece that we are going to figure out together. And we can do that through counting. On the x, we can tell that we went back 1. So my x change is going to be -1. And the y change is down 1, 2, 3, 4. Down 4. So here we have written the rule of the translation of STUV, back 1, down 4, to get S prime, T prime, U prime, V prime. That's a V in some cultures. Bad handwriting. All right, and we should be able to tell that no matter which point I pick, I go back 1, down 4. Back 1, down 4. Back 1, down 4. It's the same translation for every x, y in this quadrilateral, all right, because this is a translation. We are shifting it back and down. And now for the kind of tougher part of today's lesson. So put a little asterisk by this, the composition of rigid motions. When we are doing 2 rigid motions, a reflection and a translation, or 2 reflections, or 2 translations, then we call that a composition. We are composing multiple rigid motions. We can do 2 or more, maybe there's 3, maybe there's 4 rigid motions that we're all doing in one set of exercises. All right, so we're going to go in a particular order in which to make sure that we find out where A prime, B prime, C prime is, but then where the second one is A double prime, B double prime, C double prime. All right, so here's what's weird about this. We're going to read this from the inside out. All right, it's kind of like the order of operations, like we have to do what's inside the grouping symbols before we do what's on the outside of the grouping symbols before we do what's outside of that, right? We kind of take it piecemeal at a time. Well, here we have the reflection over line L of, that's what this little circle means, the translation back to up 5 of triangle ABC. So if I'm doing the reflection of the translation of the triangle, then that means that first I translate the triangle and then I reflect it. So this is actually first and this is actually second. And so that might be a little confusing to our Western brains who tend to read right to left. Who tend to read left to right. But the way that this works is we're working from the inside out. We're going to translate and then reflect. Translate and then reflect. Now, if I had these switched, I would reflect and then I would translate. So we're working from the inside out. Again, the way that we read this is the reflection of the translation. And so make sure that you note that that's what we're doing here, that we are doing the reflection of the translation of the triangle. Now, I don't have line L drawn in here, and so I'm not actually going to execute this, but we're going to see that on the next slide. Make sure that you articulate what step 1 is, what step 2 is, and then understand how that notation describes what is happening with that composition of transformations. Here I have 2 translations, all right? And we're going to discuss if the order here matters, all right? Maybe that's another conversation for another time, but again, this is the translation of the translation of point A. So if I have point A is at -3, positive 4, and I want to do the translation forward to, up to, of point A to get A prime, then that means that I am going to, and I'll do this one in red, I'm going to go forward to and up to. That's where A prime is. Now, if I'm going to do the translation of A prime to get A double prime, all right, we just have 2 apostrophes there. We're going to take this and move it forward 1, down 1. Forward 1, down 1. Here is A double prime. We essentially move it forward and up. All right, so there's kind of a combination here when we have a translation of a translation. So the translation forward 1, down 1 of the translation forward to, up to of point A is the same thing as the translation forward 3, up 1 of A. So even though we're doing 2 translations, we could model that as really 1 translation of forward 3, up 1. Okay? And so I want for us to be able to do this, but I want you to understand this. All right? If you can do this, awesome. You're doing the things, you're following directions, congratulations, you get an A. But to understand that 2 translations is just a translation, you will be in you'll have just a higher level of understanding, all right? This is maybe the difference between the A- and the A+, or the B+ and the A-, all right? So obviously being able to follow directions is great. Being able to conceptualize it at a higher level is really the punchline here. All right. How about we do this with a triangle? So let's go ahead and take a look at what happens with triangle ABC. If I take that point, -3, 4 again, B is -6, 3, and C is -1, -2. And what we're going to do with this triangle is we're going to take each of those things and we're going to do it 1 step at a time. So A prime, B prime, C prime. And let's talk about what each of those x, y's is. All right? So the first thing that we're going to do is add 2 and then add 2. First thing that we're going to do is add 2 and add 2. The first thing that we're going to do is add 2 and add 2. All right? So let's see how that shakes out. Let me draw my triangle. I'm going to try to be a good role model here and use my ruler. All right, I was going to try to sketch that, but I'll use the ruler so that you will use yours as well on your graph paper. You should be using graph paper for this, right? Your graph paper is required. And we are going to have now these locations. -1, +6, -4, +5, and 1, 0. This is our A prime, B prime, C prime. So we are doing this incrementally. We're working again from the inside out to try to make sure that we understand what the final result is in relation to our original triangle. All right? For A double prime, B double prime, C double prime, we are going to add 1 to each x and subtract 1 from each y. Add 1 to each x, subtract 1 from each y, add 1 to each x, subtract 1 from each y. Or we can do it, again, visually here. We're going to move A double prime is going to be 0, 1, 2, 3, 4, 5. All right, again, that's forward 1, down 1. We're going to take B, forward 1, down 1. Here's B double prime, A double prime. Forward 1, down 1. Here is C double prime. And so we end up with this blue triangle for our grand finale. Sorry, my blue marker is a little weak here. I might need to get a new one here. Maybe pause the video and come back and fix that. But here we have triangle A double prime, B double prime, C double prime. And with that, we can confirm that we have each of these at their appropriate location, all right? That we have located where each of those x comma y's are, so that we can see where our final resulting triangle is. Now, remember we talked about how a composition of translations is just a translation. So this is the same thing as translating this forward 3 and then up 1. Does that work if I take this number plus 3, I get 0, this number plus 1, I get 5. This number plus 3, I get negative 3, this number plus 1, I get 4. This number plus 3, I get 2, this number plus 1, I get negative 1. And so we're moving forward 3, up 1, forward 3, up 1, forward 3, up 1. We can confirm that a translation of a translation is a translation. All right, so maybe we can have a rule here where we have a translation x1, y1 of a translation x2, y2 is equal to a translation x1 plus x2, comma y1 plus y2. All right, that's kind of a notation that we can use. If it's helpful to think about it that way, great. If that overcomplicates it for you, do things piecemeal. Do things one at a time, either in your head and on paper, or in graph paper representing each of those steps. All right, we do want to show all 3 pieces, the original, the translated once, and then the translated twice. All right, let's do a reflection here. Let's see what happens when we do this reflection. This will be kind of the last one, and we'll discuss this again. When I translate a translation, I get a translation. What happens when I reflect a reflection? All right, so again, the x-axis is this horizontal line, which is the same as y equals 0. All right, the x-axis is that horizontal line, y equals 0. So this is, again, we got to review. How do I reflect? So when we reflect over, I'll do red first and blue second. When I reflect over the x-axis, all that I am changing is the y value. The x value stays the same, the y value goes negative. The x value stays the same, the y value goes opposite. The x value stays the same, the y value goes opposite. When we reflect it over, the x value stays in the same place. We're just flipping the triangle. So again, A, B, C, negative 6, 3, and negative 1, negative 2. Here's A, B, and C. When we flip those, when we reflect them over this line of reflection, we are now getting negative 1, positive 2, and negative 3, negative 4. Here's A prime, here is C prime, and then B prime is going to be 3 spaces below. And you can see that our red triangle is a reflection of the black triangle, the original triangle. So again, I know this is taking a little bit of a longer time in this explanation because I'm having to do all of this work while you are doing all of that work. Hopefully it's not taking you too long compared to how it would usually take you. But we're able to kind of connect these dots. We're not just writing new things, we're not doing that stuff. But you can see that this red triangle is a reflection of the black triangle. Now, again, we're doing first and then we're doing second. So now I'm going to reflect this red triangle over the line y equals 3. Now this is a little bit tricky because we're not reflecting over an axis. We're having to find out where's the line y equals 3. And we're going to reflect this equidistant from that line. So if this is 1 space away, I'm going to go 1 space away for C double prime. If this point is 1, 2, 3, 4, 5, 6, 7 spaces away, then I've got to go 1, 2, 3, 4, 5, 6, 7 spaces away on the other side. If this is 1, 2, 3, 4, 5, 6 spaces away, then I need to go 1, 2, 3, 4, 5, 6 spaces away on the other side. And so we can see that our final result is a congruent triangle, right? Same segment lengths, same angle measures. It's just moved, all right? It's a rigid motion. So our black triangle and our blue triangle are the same. Right, so now here's what I want to show you. If I get rid of the red triangle, don't erase it on your paper, but if I get rid of the red triangle, we should be able to write a rule for what has happened. Can you think about what has happened from our original triangle ABC to our new triangle A double prime, B double prime, C double prime? How is A, B, C double prime related to our original triangle? All right? What has changed? Instead of calling this a reflection of a reflection, what can we call it? All right, so I want you to kind of think through that. That's kind of a punchline to this conversation, and so let's go ahead and well, I guess I'm giving you the answer here. It's basically we moved the thing up. All right, we moved it up. When I did this reflection of this reflection, you should see that all that we have here is actually translated this figure left or right 0, but up 6. All right, I didn't know that I had that actually typed in there. Well, I knew that it was, I tried to click through it, and then you probably saw it. So here we have this translation as a composition of reflections. Here's a question that I want to ask you though. How can you predict this translation? How can you predict that the actual change is left or right 0, but up 6? How do you know? And so that's what we want for you to try to explain here. So try to explain that. How do you know you get from this double reflection to specifically this translation of up 6? We reflected over 3, we reflected over 0 for y equals 3 and y equals 0. How do we know that we're going to end up 6? All right, that's kind of the finale, that's the end. Hopefully you can see how a translation changes our picture.